Hey everyone, and welcome to this explainer. Today, we're diving into what is honestly a monumental shift in the timeline of our digital security. If you follow the evolution of our digital infrastructure, you probably already know that the cryptographic standards we rely on every single day, well, they have an expiration date. Based on our source material today, we are unpacking the reality of the quantum threat to global cryptography. And look, we aren't talking about some theoretical, maybe in 100 years vulnerability here. We're exploring a fundamental hardware revolution that is absolutely poised to make modern encryption completely obsolete.
The source text we're looking at lays out the premise with zero ambiguity. I mean, listen to this quote, "Why it will break every password on Earth." The narrative here isn't dealing in probabilities or what-ifs. It presents a definitive ticking clock endgame for our current cryptographic paradigm. We are essentially looking at a hard limit on the lifespan of contemporary digital security. And it's driven by a massive technological leap that simply bypasses the mathematical walls we've spent decades building.
So, what does this all mean? Well, first off, this isn't just a pesky software bug that you can patch over the weekend. Actually, scratch that. It's not a bug at all. It's a structural inevitability. The ultimate threat to our digital infrastructure stems from the impending obsolescence of our current math. Our standard encryption algorithms basically rely on the sheer, mind-boggling amount of time it takes classical computers to factor incredibly large prime numbers. It would literally take thousands of years. But the quantum threat is so profound because it fundamentally rewrites those rules. It takes a computational problem that would take thousands of years to solve and turns it into one that could potentially be cracked in a matter of hours. No way around it.
Now, the catalyst driving this crazy timeline is, of course, quantum computing. Instead of operating in your standard, everyday binary, ones and zeros, quantum processors leverage qubits to exist in multiple states simultaneously. So this isn't just a faster processor, it's an entirely different computing architecture. It represents an unprecedented leap that's capable of executing incredibly complex operations, like Shor's algorithm. And Shor's algorithm is specifically designed to unravel the exact prime factorization that underlies all of our modern public key cryptography.
And this amazing hardware revolution is pointed directly at a very specific target, global cryptography. We are talking about the mathematical backbone of modern trust. Think of protocols like RSA and elliptic curve cryptography as the invisible digital locks that secure literally everything. From global financial transactions to highly classified communications, they keep it all safe. But at their core, they're just highly complex math problems. And what our source is telling us is that our global cryptographic infrastructure is suddenly staring down a specialized hardware solution that was built precisely to solve that exact math problem.
So we're essentially watching a severe asymmetry unfold right before our eyes. It's current cryptography versus the quantum threat. Decades of entrenched, globally integrated security infrastructure are now finding themselves completely outmatched by a totally new computing paradigm. It takes an immense amount of effort and coordination to establish a secure global standard, right? But the quantum approach effectively sidesteps those deeply entrenched defenses entirely. It literally changes the fundamental physics of computation to break what classical computing simply cannot break.
I want to circle back to a specific word from our source quote, because the absolute gravity of the word every points directly to a massive vulnerability in our system architecture. It highlights a really critical lack of what the industry calls crypto agility. Most legacy systems, and we're talking everything from a local enterprise server to vast governmental databases, they just weren't built with the ability to simply hot swap encryption standards. When the core cryptographic foundation breaks, every single system built on top of it becomes compromised. It absolutely doesn't matter how complex your individual password or access protocol might be, if the foundation crumbles, the whole house comes down.
Think about the real-world scale of upgrading these vulnerable systems for a second. Historically, migrating global security protocols takes well over a decade to fully implement across online banking, personal emails, corporate infrastructure, and government networks. Yet, the ticking clock of quantum advancement definitely doesn't wait for bureaucratic IT cycles. The protocols protecting these critical sectors are deeply hard-coded into millions and millions of devices. So, we're looking at an incredibly tense race between the slow, arduous process of systemic security upgrades and the rapidly accelerating pace of quantum processing power.
And to make matters worse, the scope of this threat is entirely borderless. The source said on Earth, right? This introduces a really terrifying, absolutely crucial concept known as harvest now, decrypt later. State actors and malicious entities are out there right now actively intercepting and storing massive tranches of highly encrypted data.
Sure, they can't read it today, but they don't need to. They're simply stockpiling it, just waiting for the day that quantum computing matures enough to retroactively strip away that encryption. When that happens, boom, decades of highly sensitive global intelligence are instantly exposed.
The trajectory outlined by the source material follows a really rigid, undeniably chilling logic. It's basically a three-step timeline. First, quantum computing advances past the threshold of classical simulation. Second, global cryptography fails because those foundational math problems are finally and reliably cracked. And third, the passwords and firewalls relying on that cryptography systematically break. The whole situation moves relentlessly from theoretical physics straight into an engineering challenge and ultimately culminates in a total compromise of our current data protection standards.
Ultimately, we are staring down a monumental engineering challenge to prevent a totally unsecured future. Transitioning to a post-quantum world means entirely overhauling the digital bedrock we've relied upon since the dawn of the internet. The text leaves zero ambiguity here. Current encryption will fall, for sure. So the focus is now shifted urgently to quantum-resistant algorithms. It's a complex, unbelievably costly race to rebuild a secure foundation before the hardware capabilities catch up and render our existing safety nets completely obsolete. Which leads us to a profound, massive question that we all have to grapple with right now. What actually happens when every digital lock on Earth simply breaks? If the foundation of our digital trust vanishes overnight, the very fabric of our modern connected world is fundamentally redefined. I'll leave you to consider that reality as the quantum horizon approaches. Thank you so much for joining me